In this video, I'm going to show you how to solve the ALEKS problem called identifying the parts of a sphingomyelin. This problem has two parts to it. It's going to ask you first of all to just say what type of molecule this is. This type of molecule is a sphingomyelin, kind of like a trick question. Also, the second portion of the problem is going to ask you what are the three different components of this sphingomyelin. So first of all, the portion in B, that is just a characteristic for all sphingomyelins, that is called sphingosine. The portion that's highlighted in green, that identified as part C, this is a fatty acid, or it came from a fatty acid. So what you're going to need to do to identify this particular portion is go into the ALEKS data tab. There is a data table full of fatty acids. I've got it copied over here so we can reference it. And what you're going to need to do is match up the carbon skeleton of this portion with the correct fatty acid from ALEKS's data table. It looks like it's a pretty small fatty acid with a carbon-carbon double bond towards the end. I kind of feel like maybe it's this one right here, lauroleic acid, but we want to count carbons to make sure that that's correct. Actually, the more I look at it, I think maybe it's myristoleic acid. So here I have 9 carbon atoms, starting at the carbon-oxygen double bond, 7 more, and then 1 more. 9 carbon atoms before we start a carbon-carbon double bond, and a total of 9, 10, 11, 12 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's actually too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I was right the first time. It's lauroleic. Now in ALEKS's data table, it just says lauroleic, but it wants you to put acid at the end of that. It is lauroleic acid. ALEKS is just kind of abbreviating these over here, and it's leaving the acid off of the end of each one of these guys, but you're going to want to include it when you're answering the question. Now, last but not least, we've got this last component in pink, part A. There are 3 different types of molecules that you could see in this particular portion of the fatty acid, of the sphingomyelin. And we're actually going to refer back to the last problem I solved to give us the structures of these 3. So one option that we have, the one that we're looking at, is choline. On the problem that we're dealing with right now, that structure is called choline. We can identify it. Oh, now that I look at it, I see I'm missing a bond there. Right there. So we can identify that choline molecule because it has a nitrogen with 3 methyl groups attached to it. And that's what we have here, nitrogen with 3 methyl groups attached. So that is choline. Now we've got 2 other options, 2 other types of molecules that could be appearing in this spot. This is ethanolamine. You'll be able to identify it because it's a nitrogen with just 3 hydrogens attached. And the other option is serine, and you'll identify that because it will have a carbon-oxygen double bond, COO-.